and start sharing the screen. And oops, you guys don't need to see all of this stuff that I have open for the faculty senate meeting. You need to see the important stuff, the start of the notes for today. We're going to start looking at rational expressions. I really like following the factoring with the rational expressions because it kind of gives meaning to what we did factoring. I know when we factored it kind of, I know for most people it kind of looks like, well, this is sort of interesting, but why are we unmultiplying? What's the purpose of it? And we saw in solving quadratic equations, one of the reasons that we have to be able to factor in order to solve those equations with exponents. And we're going to see that these rational expressions are also a place where we really need to have strong factoring skills to work with. Exam 4 is going to be on rational expressions and radicals. It'll be in my labs for you to work on probably on December 10th. The final exam will be in my labs for you to work on December 17th. That's that last Thursday. Everybody listen up. The final exam, you will not have a 24-hour period in which to take it. It will probably be open from 8 in the morning to 8 in the evening during the course of the day. If those hours do not work for you, contact me. But it's probably going to be open on the 17th from 8 a.m. to 8 p.m. I can't give you that longer 12-hour period because the way in which the college expects me to turn around, grade your exams, and submit your averages, I can't leave you that long turnaround period. Next homework is homework 32, which is on what we're looking at today, simplifying rational expressions. That will be due after Thanksgiving. Again, if this time frame for the final does not work for you, talk to me. Okay? Any questions about any of that? If not, we're going to start looking at rational.
I just have another question.
Okay.
We don't have school Thursday, right? Like class.
Right. It's Thanksgiving.
Okay.
So there's no classes Thursday or Friday this week. So tomorrow, Wednesday, is the last day of classes this week. Do you guys have any fun plans for Thanksgiving?
No.
No? Okay. Are any of you responsible for that challenging part of Thanksgiving, making the dinner? Yeah? Okay. My theory on Thanksgiving is the sides and the vegetables are the most important part. That's biased because I'm a vegetarian. So the other thing in terms of pending holidays that blew my mind when I wrote this page out this morning, looking at it being November 24th. Can anybody believe we're only a month away from Christmas Eve? It's like, oh my God, I have so much things to do in the next month, especially because we're probably not going to be gathering as a family for the holidays. So everything's got to be ready to ship, right? So, oh boy. Yeah.
Okay, what do you have for turkey replacement as a vegetarian? My daughter's a vegetarian.
You know what? Look at your Thanksgiving dinner. What is there? There's turkey, and at least in my household, a million vegetables and starches.
Yeah.
And so usually the million vegetable and starches do me fine. I know, like, what was flavor from my childhood growing up for Thanksgiving. My mom used to always stuff half the bird with Uncle Ben's wild rice mix. And so, the wild rice, when we make the stuffing, we use vegetable broth instead of turkey broth. And so that the stuffing is vegetarian. Of all of the roasted vegetables, the salad, the potatoes, the all of that. Yeah, I mean, if you think about it, everybody makes the big big deal about the turkey, but when you look at your plate on Thanksgiving Day, at least in my house, it's overflowing with a hell of a lot of things that aren't turkey. And it's really easy to make those. I think the challenge was once when my son was in college, he brought his roommates here for Thanksgiving. And one of his roommates was a vegan. And going that extra step of making part of the meal vegan, which meant like not using the eggs and dairy product, made it a little bit more challenging. Uh, but, you know, we came up with substitutions for whipped cream and all of that and made it work. So, but you know, it's, yes, I guess there isn't a vegetarian protein there, but there's an awful lot of vegetables there that kind of make up for it. Yeah.
Enough to fill you up.
Yes. And keep you happy. And even like I used to love mincemeat pie, but you can make mincemeat pie without the meat, right? It's all the vegetables too. So
I didn't know mincemeat pie actually had meat in it.
yeah, that's why it's called mincemeat. It was I think back in ancient times, it was a way of preserving meat. And if you look at like my mom used to always buy the little dehydrated boxes of mincemeat that you reconstitute it. My God, I can picture it. I can't remember the name of the brand. And if you read in the ingredients, like in the fine print, there's probably like, you know, a quarter of a slice, you know, a sliver of bacon or something chopped up in there somewhere. There isn't. Make it on your own with the orange and the apples and the cloves and the cinnamon and the raisins. It's, you know, it's also vegetarian. But I digress.
Thank you.
Now we're going to start looking at rational expressions. And before we look at rational expressions, I want to think way back to one of the things that we did early on in the semester. And we looked at the idea of rational numbers. And when we looked at the idea of rational numbers, I always like to point out that if you look in that word rational, at its root is the word ratio. And so they're a ratio of integers. And when we talked about ratios, we said they could be written with words. They could be written as A to B. They could be written with a colon, A colon B. But the most practical way of dealing with a ratio is a fraction. So rational numbers are numbers of the form A over B, where A and B are integers. And we also had to make sure that the denominator is not 0. Does everybody remember that the denominator of a fraction cannot be 0? And so examples of rational numbers might be something like 3/4. Examples of rational numbers might be something like -7/9. And well, all of your numbers that can be expressed as fractions. Those are rational numbers. When I look at instead rational expressions, again, they're rational, so they are a ratio. They're a ratio of polynomials. They're of the form P over Q, where P and Q are polynomials. And because they're fractions, we also have to specify that Q cannot equal 0, that the denominator cannot be 0. Some people refer to them as algebraic fractions. So think about everything that we did with polynomials: add, subtract, multiply, divide. Think about everything that we did with ratios and fractions, and we're going to be putting them together. An example of a rational expression in algebraic fraction might be something like x squared plus 1 over 3x plus 6. And hopefully everybody is familiar with the terminology. The top of the fraction is called the numerator, and the bottom of the fraction is called the denominator. So far, so good?
Yep.
Everybody right if I turn the page? So then what we have to remember is a rational expression is undefined, meaning it has no meaning. It's undefined if the denominator is 0. And so you might see a question like the following. The directions might say find all values for which the expression is undefined. And let's look at that rational expression that we just wrote. Let's look at x squared minus 1 over 3x plus 6. And again, we have to realize that for it to be undefined, it means that the denominator is 0. So in order to answer this question, there are two things that we have to do. The first thing that we're going to do is we're going to set the denominator equal to 0. We're going to ignore the numerator. I don't care what's in the top of that fraction. If I'm looking to see where a fraction is undefined, I'm going to take that denominator and set it equal to 0. When we do that, does everybody see that gives me an equation to solve? And so I'm going to solve that resulting equation. So how would you solve 3x plus 6 equals 0? What would you do?
Track 6 and
Subtract 6 from both sides. Beautiful. Gives me 3x equals negative 6. Now what?
divide by 3. Or, yeah.
Wonderful. Dividing by 3 gives me x equals negative 2. And so that would be my answer. We'd say that it's undefined when x equals negative 2.
Because that's less than 0?
No, because if x is -2, when I look at, we'll put a little cos here. When I look at what was my fraction, x squared minus 1 over 3x plus 6. If x equals -2, that would be -2 squared minus 1 over 3 times -2 plus 6. So I think that top works out to be 3, but that bottom works out to be 0. And it's undefined there because we cannot have 0 in the denominator.
Oh, okay, if we checked it out. Okay, thank you.
Okay. So let's look at another one. When is x minus 3 over x squared plus 5x plus 4 undefined? And again, just like above, if I'm looking for where it's undefined, I don't care about the numerator of the fraction. The numerator can be anything. I care about the denominator of the fraction, and I worry about where it's equal to 0. Again, we only focus on that denominator. Now, this is like one of those questions that we ran into at the end of last unit, last week, where we said if we have an exponent in an equation, we want to make one side 0, and then do you remember we said we wanted to factor? This is one of the ones that isn't too challenging because we've got 1x squared. So we know they're gonna start with x's. Because this is a positive 4 at the back, we know that our signs are the same. And because that's a positive 5, we know they're both pluses. And then if we look at the factors of 4, 4 can be 1 times 4 or 2 times 2. Which of those would give me a 5 in the middle?
So 1 and a 4.
The 1 and 4. And then remember we had said if they multiply to 0, that means one of the two of them is 0, and we don't know which. So we're going to end up setting each of them equal to 0, which gives us two smaller equations to solve. On the left, if I subtract 1 from both sides, I get x equals -1. On the right, if I subtract 4 from both sides, I get x equals -4. So in a sentence, I'd say it's undefined if x equals -1 or x equals -4. Another way of saying it, other than that it's undefined there, is to say that x cannot equal -1 and x cannot equal -4. And I think in my labs, I can't remember if they use the not equal or where is it undefined, but they'll give you a little box to fill in, and you'll just put in your -1, comma, -4. And again, it's undefined there because if I put those numbers in for x in my original equation, fraction, pardon me, not an equation, it's an expression, no equal sign. But if I put either of those numbers in for x, when I work it out, I'll have a 0 in the denominator, which I cannot do. One more?
Sure.
Next. Go ahead.
This doesn't seem hard so far.
No, next one is mind bending, but probably the easiest. Next one asks, when is x cubed plus 17x squared minus 30x over 5 undefined? And again, when I see this undefined, it's telling me that I only look at the denominator. And I look about what makes the denominator equal to 0. So here my denominator is 5. And so that would give me 5 equals 0. Hey, does 5 ever equal 0?
No.
No. So this one is never undefined. That denominator will never equal 0. And so I don't have to worry about it at all. So I'm going to shut up and give you folks one last one to work on your own. This time I'm going to ask, when is 15x plus 7 over 2x squared minus 50 undefined? And while you guys do that, I am going to get up for a minute and scour my office for a cough drop. I'll be right back. It wasn't as bad as I thought. Last night I spilled a glass of water all over the desk. And this desk has been sitting here unused for a very long time. It's a mess. There are papers and pictures everywhere. And they all got wet. And so everything went flying, and now I have stacks of paper drying in every corner of the room. So I thought it would take a lot longer to find those cough drops. How are you folks doing? Did anybody else get that it's undefined at -5 or 5? You folks there?
Yep, I got almost down to the.
Okay, did I go too fast? I'm sorry. I should have
No,
given you more time. I'll shut up. We good or no?
Yep.
If that's all right, we know to figure out where a rational expression is defined or undefined. The next skill that we have to have is to evaluate a rational expression.
So I'm sorry, was that one defined or undefined?
That
I don't have to do it out, but if I put the -5 or 5, I'd have to do both of those in the equation to figure it out, right?
What should happen is if you put -5 in, you'd have a 0 in the denominator. And also, if you put +5 in there, you'd have a 0 in the denominator. And so those are the two numbers that you cannot put in for the variable in this equation, in this expression, pardon me. You can put any other number in the universe in for x. The only numbers you cannot put in for x are 5 and -5.
Okay.
Okay?
Yep.
So I don't know how I ended up with the blank page, but if I look at evaluating a rational expression, this is just like evaluating any other expression. You substitute the given value for the variable. Then simplify. When you do this, it's important that you remember your order of operations. And with the order of operations, you have to remember that there's an invisible parentheses around the numerator and the denominator. When I look at my fraction with the numerator over the denominator, I see it as parentheses around the numerator and then parentheses around the denominator, which means you have to first simplify the numerator. Then you have to simplify the denominator. Then simplify the resulting fraction. So, do I need to be quiet for a minute for writing purposes, or are we all ready to roll?
Oh, good.
So an example might ask you to evaluate x plus 4 over 2x minus 1 if x equals 3. The directions for something like this usually have in fine print at the bottom, write as a ratio of integers, simplify. So first of all, let's go through and do our work. We've got x plus 4 over 2x minus 1. And we're substituting x equals 3. So that's going to give me 3 plus 4 over 2 times 3 minus 1. And especially if you're a person who's going to try to use a calculator to simplify this, what you have to remember is there's a parentheses around the numerator and the parentheses around the denominator. And if you're using a calculator to simplify something like this, you need to include those parentheses. So first, numerator 3 plus 4 is 7. Then denominator 2 times 3 multiplying first would be 6 minus 1 is 5. And now, don't think that fraction can simplify. And so this is my final answer. When they say write as a ratio of integers, they're telling you to leave it as a fraction. A ratio. They don't want a decimal, and they do not want a mixed number. That right as a ratio of integers means we just want a single fraction as our answer. So let's try a couple more of these. Can I scooch this up?
Yep.
Next example, let's evaluate x plus 4 over 2x minus 1 if x equals negative 2. Now I'm going to be quiet for a minute and let you folks look at that. Did everybody get 2 in the numerator and negative 5 in the denominator?
Yes.
Okay. With something like this, when you type it into MyLabs, they should accept it in one of 3 ways. We can look at that as 2 over negative 5. Positive divided by negative would be negative. Or we can look at it as just the negative fraction, negative sign in front of the fraction. Or we can look at it as -2 over 5. What's important is that as long as there is only one negative sign, it doesn't matter if you write the negative sign in front of the denominator, if you write the negative sign in front of the numerator, or if you write the negative sign in front of the whole fraction. It's just important that there is only one negative sign. Okie dokie?
Yep.
And then one more. Let's evaluate 6x minus 7 over x squared minus 2x plus 3 if x equals 2. How are you folks doing?
Good.
Did anybody else get the fraction 5?
Yes.
Great. If that's all right, then you know how to tell where a fraction is defined. Well, actually, where a fraction is undefined, right? We know how to evaluate a fraction. The other thing that we're going to look at today is the idea of how to simplify a rational expression. And before we go through and simplify a rational expression, let's see if we can remember how to simplify a rational number. So, for example, if I have the fraction 5 over 10, can everybody recognize the fact that that fraction can be simplified? Can anybody remember how to simplify it, how to reduce a fraction?
Yeah.
What should I do?
BCF or common factor.
Common factor between 5 and 10 would be 5. And then we're going to divide them both by 5. Get 1/2. Another example, if I have 18 over 27, oops, you know what? I apologize. We can think of it as dividing it that way. Or can I think of it where I have 5 over 10? I can think of that as 5 times 1 over 5 times 2 and divide out that common factor to get a half. So over in the second example, is there a number that goes into both 18 and 27? Can anybody think of one?
Nine.
9. And so 18 would be 9 times 2. 27 would be 9 times 3. And so my simplified form would be 2/3. We're going to do the same type of thing using this method of factoring to simplify a rational expression. First, let's define what we mean by simplified form. We'll say that a rational expression is in simplest form if the greatest common factor of the numerator and denominator is 1. So we want to make sure that the greatest common factor of the numerator and the denominator is 1. We're going to see, to simplify a rational expression. Whoops. The first thing that we're going to do is we're going to factor both the numerator and denominator completely. And then I'm going to put in quotes, divide both by any common factors. And so let's go through and let's look at an example. The directions are going to say for all of them, simplify each. So first one I'm going to have is x squared plus 4x over 2x plus 8. And here, when I look at this fraction, what I really see are two factoring problems. So for just a minute, I want to ignore the denominator, pretend it's not there, and ask you to factor the numerator. When I look at x squared plus 4x, does everybody remember that factoring checklist? First thing I see is they're a common factor. Is there anything common between x squared and 4x?
X.
Beautiful. And now their common factor is x. When I think of dividing it out, x squared divided by x would be x. 4x divided by x would be 4. There's nothing else in common, and there's no exponents left, so that should be factored completely. Now, we're going to do the same thing, forget the numerator and look at the denominator. Again, when I factor, the first thing I look for is something in common. Is there something in common between 2x and 8?
Two.
2. And when I divide out that 2, 2x divided by 2 would be x. 8 divided by 2 would be 4. Now, I want to step back and look at the big picture. Is there any factor common to the numerator and the denominator? Is there any factor that's the same? And hopefully everybody sees that they both have that factor of x plus 4. And so when I divide out the common factor, we're dividing it out. I usually just think of crossing it out. And so my simplified form would be x over 2. Another example, same directions. Let's say I have x squared minus 4 over x squared minus 5x plus 6. Here, I have to factor the numerator. When I look at that numerator first, I don't see anything in common. After we common factored, we said the next thing we do is count terms. There are 2 terms. It does have subtraction in the middle, and they're both perfect squares. So does everybody remember the difference of squares factors into the sum and difference of their roots? X squared would be x times x. 4 would be 2 times 2. That was one of the common careless mistakes that I did see on that last test. Some people did a great job recognizing the difference of squares, did a great job realizing you were going to have the sum and difference, did a great job with the x squared being x times x, but then they messed up and didn't put in the 2 2's. They put other numbers there. Be careful. Those 2 numbers have to multiply to the second half of your binomial. Now in the denominator, we have a trinomial. So we're going to look, no common factors. We're going to look for 2 binomials that would multiply to give us this. To multiply to x squared, they'd start with x times x. Last term is positive, so the signs are the same. They'll both have to be minus signs. And now with 6 in the same signs, we're looking for numbers that would multiply to 6 and add to 5. Any ideas? Six could be 1 times 6.
2 and 3.
Or 2 and 3. Beautiful. So x minus 2, x minus 3. Now, I want to look at that and say, is there anything in the numerator that matches with the denominator? And they both have that x minus 1, so I can divide it out, and I'm left with x plus 2 over x minus 3. I like to say that fractions are fun if you factor first, because that part crossing out, I think, is kind of fun. But we can only cross out factors. For a second, I'm going to play devil's advocate, and I'm going to look at this fraction. Does anybody think that what's left can be simplified further? The answer is no. We have to stop here. One of the most common careless mistakes that I see is people trying to reduce, divide out those x's. Does everybody see that this x is being added? This x is being subtracted. Those x's have to stay because they're not factors. You can only divide or cross out common factors. They have to be things that are being multiplied. They cannot be things that are being added or subtracted. That one, all right.
Yep.
And the next example, I think I like to treat a different way. Next example, I have a to the third, b to the second, c over a, b to the third, c. And if I have one like this, where I have single terms in the numerator and denominator, I like to just use my exponent laws. We worked real hard on mastering those. And with a problem like this, I think applying that skill that we have is the easiest approach. Does everybody remember seeing a question like this in that exponent chapter where we're asked to simplify?
Yep.
Does everybody remember when I look at that a to the third, b to the second, c over a, b to the third, c? Anything without an exponent, I can think of having an exponent of 1. And does everybody remember when we divide on those common factors, we subtract the exponents? So that would be a to the 3 minus 1, b to the 2 minus 3, c to the 1 minus 1. Does everybody remember when we divide, we subtract exponents, the exponent of the numerator minus the exponent of the denominator? Then doing that subtraction, we get a to the second, b to the negative first, c to the 0. And then we have to remember that c to the 0 is just 1, and we don't need to show that. So that gives me a to the second, b to the negative first. And then we said we don't want to leave a negative exponent. If we have a negative exponent, we're making a fraction. Does everybody remember the a has a positive power, so it goes in the numerator. The b has a negative power, so it becomes positive when I put it in the denominator. So my answer would be a squared over b to the first. But because mathematicians are lazy, we don't write that exponent of 1, so we'll think of that as a squared over b. Or we could do it another way. We could look at that a to the third, b to the second, c over a, b to the third, c. And we could find the greatest common factor of the numerator and denominator. And so the greatest common factor, let's see, they each have an a, they each have a b, they each have a c. Lowest exponent on a is 1. Lowest exponent on b is 2. Lowest exponent on c is 1. And so if I think of taking that common factor out of each, if I divided that by a b squared c, I'd have left a factor of a squared. And if I divide my denominator by a b squared c, I'd have a factor left of a b. And when I divide out that common factor, I get a squared over b. Please notice that both methods take me to exactly the same place. It's just a matter of personal preference. If you're more comfortable working with your laws for exponents, go for it. If you're more comfortable finding that common factor, factoring it out of numerator and denominator, and then reducing, you can go for that too. They both take you to the same place.
Can I ask a quick question?
Sure.
So I like the GCF one. That seems, and I like, I mean, I can do both ways, but can you just show me how you would factor out the a b squared c from those? It would be from the numerator and the denominator. Could you just write that?
Sure. Where I have a to the third, b to the second, c, I want to think of that as a b squared c times something. And so I guess what I'm doing really is using my exponent laws. A to the third divided by a to the first is a to the second. B squared divided by b squared is 1. C divided by c is 1. So I'm kind of, in my mind, I'm thinking, I'm taking that numerator and dividing it by the common factor to get the a squared. You know what I'm saying?
Yep.
I'm dividing it out. And so in the same way, when I have that denominator, which was a b cubed c, and when I divide that by the a b squared c, I'd be left with b. And so that would take me there. Another example, let's simplify. Let's look at x squared y cubed z over x y squared z squared. And I'm going to be quiet for a minute and ask you to do that one either by common factoring or by using your exponent laws, whatever works best. Can you guys hear me? Can you guys hear me?
Yes.
Okay, because just for a second, something came up that told me that I had no internet for a second. Did anybody else get XY over Z?
Yep.
Great. Then let's try some other problems that are a little bit different. This time, let's look at x to the fourth plus x to the third over 5x plus 5. First of all, is everybody all right that I can't just use my exponent laws with these because of the addition in the middle? Because they're binomials, we have to factor first. So when I factor that numerator, x to the fourth plus x to the third, is there a common factor between the two of them? Is everybody all right? They each have an x. What's the lowest exponent on x in that numerator? The lowest exponent is 3. When I take x to the fourth and divide it by x to the third, I get x. And when I take x to the third and divide it by x to the third, anything divided by itself is 1. In your head, think, whenever I factor, I want to do a mental check. If I were to distribute back, would this take me to that numerator? Sure enough. Now, let's look at the denominator. In the denominator, 5x plus 5, is there a common factor? 5. And when I take 5x plus 5 and divide it by 5, wouldn't I also get x plus 1? Again, check, distribute back, make sure you'll get your denominator. Now that we've factored first, can we have some fun? Is there anything we can cross out? The x plus 1s. And while looks like we're just crossing them out, what we're really doing is dividing out their common factor. And so our final answer will be that x to the third over 5. Shall we try another?
Yep.
This time, let's simplify. Let's say I have 3x squared minus 12 over 6x minus 12. Before we begin, remember, you can only divide or cancel factors. So no matter how much you want to start crossing things out right now, looking at this fraction, you can't. You must factor first. So this is really right now two factoring problems. If I asked you to factor 3x squared minus 12, first we would need to look for something in common. Is there a common factor between 3 and 12? They're both divisible by 3. Taking that out would leave me with x squared minus 4. But now we're not done. And that was another mistake that I saw in the test. Some people factor halfway, but never finished. This is the difference of squares. It can still be factored. It's a binomial. They're both perfect squares with a minus in between. X squared would be x times x. To get a negative 4, one's positive, one's negative, and they're both 2's. Now, that's factored completely. Now we want to factor the denominator, 6x minus 12. And with 6x minus 12, there's a common factor of 6. And then I'll have my x minus 2. And I don't think that factors further. So I'll leave this as 6 times x minus 2. Now that they're factored, is there anything in common? Well, they both have that x minus 2. So right now that would leave me with 3 times x plus 2 over 6. Then does everybody recognize that the 3 and the 6 have a common factor of 3? So I can think of dividing this by 3, and I'd be left with 1. And dividing this by 3, I'd be left with 2. And so my final answer is 1 times x plus 2, which is just x plus 2 over 2. And then we'd stop here. We'd have to stop because, again, we can only cancel factors. Does everybody see in the numerator that 2 is being added, not multiplied? So we've got to leave those 2's alone. And then I just have 3 more that I'd like to do with you. And they kind of fit a special case. So let me add a page. Is everybody all right with this one? Should I play devil's advocate and talk about what are the most common careless mistakes? Or should we just ignore the mistakes and go with just looking at what's the right way of doing it? Not hearing anything, I'm going to leave it. And so the last that I'd like to look at is to simplify something like x minus 5 over 5 minus x. And here, does everybody notice that I've got 2 binomials, neither of them factors, but they look so close, but they're not the same. Well, I'm going to do a little bit of scribbling my thoughts down below. If I look at x minus 5 and 5 minus x, I would say that they are opposites. Two ways of showing that they're opposites. If I were to take x minus 5 and multiply it by -1, distributing, it would give me -x plus 5, and then commuting, I could look at that as 5 minus x. So one is the -1 times the other. So if I have a fraction like x minus 5 over 5 minus x, where the two polynomials, the binomials have the same terms. They're both subtraction. But the subtraction is reversed. They're opposites. And so that will reduce to -1. So if I have a minus b over b minus a, I notice they're both binomials. They look very much the same. They're both subtraction. The order is reversed. That will reduce to -1. But be careful. If I have a plus b over b plus a, that's going to reduce to +1 because these are addition. And with addition, order does not matter. So those two are the same. And so let's look at one last example. Let's look at ten minus 5x over x squared minus 4. To factor 10 minus 5x, we have a common factor of 5. And when we divide that out, we're left with 2 minus x. To factor x squared minus 4, that is the difference of squares. And so that'll be x plus 2 times x minus 2. These two are almost the same. They're a binomial with subtraction, but the order is reversed. And so we just said that those would cancel to -1. And so usually you show that by putting a negative in front of that remaining fraction. So that when those cancel to -1, you can show multiplying by -1, or you can just show putting a negative sign in front of that remaining fraction. And to the best of my knowledge, that was as far as I wanted to get today. How does it look? Any questions?
Not too bad.
Not too bad. And do you notice, I know we could spend forever. We could spend the rest of the semester just factoring. And people, like they feel like they're banging their heads against the wall factoring. But once we start using it to do something constructive, like reducing fractions, all of a sudden it seems to just click a little bit better. So
Yes.
hopefully, the fact that now when we're factoring with fractions, we're hoping we get something that matches up. It seems to kind of, by putting meaning to it, make it a little bit better for folks. So, okay. Anything else I can do for either of you today?
No, I'm all set.
All right. Well,
Thank you.
have a great Thanksgiving. Enjoy your long weekend.
Yes, you too.
All
See
right.
you next week.
All right. Thanks.
All right, bye-bye.
Okay. Oh, I was going to ask Cade, but he's gone. So bye-bye. Have a great one.